Consider an object like an elephant standing on solid ground. As the elephant is stationary, there is no net acceleration, and Newton's second law tells us that there must be no net force. Since the elephant has mass and gravity is acting on it, the elephant is applying gravitational force to the ground. This gravitational force is also called weight, which we will discuss in the next video, but for the time being, we'll call this force gravitational force. Now, since the elephant is not moving, then there must be an opposing force that the ground exerts back on the elephant to counter against this gravitational force. This reactive force is due to Newton's third law, which states that for every action there is an equal and opposite reaction. Newton's third law gives rise to a very important force called the normal force. The normal force is a reactionary force and has a symbol F with the subscript letter capital N. The normal force is what prevents us from sinking into the ground or crashing through a table when we're standing on it. In mechanical physics, the word normal is a geometric term to mean perpendicular. So the normal force acts in a direction that is perpendicular to the surface or the plane which an object is in contact with. The following illustrations give some example of the directions which a normal force acts in. If the mass is in contact with a flat horizontal surface, then the normal force acts straight up to oppose against the force of gravity, which is directed straight down. If the mass is on some inclined surface, then the normal force will be directed at an angle that is perpendicular to the incline. Basically, the normal force will be the force that prevents the mass from breaking through a surface that it's in contact with. If the mass is not in contact with any surface, then there is no normal force required. As the normal force is a reactionary force, it acts to balance out any applied force on the surface. So for a small mass sitting on a horizontal surface, the normal force will be equal to the gravitational force on that mass. As the mass gets larger, so too does the gravitational force acting on it, and therefore the normal force is increased proportionally. However, the normal force will never be greater than the applied force. If this was the case, then this would result in a net force in the upward direction, causing an acceleration, and the mass would fly up into the air. The normal force reacts such that the net force perpendicular to the contact surface is always zero. Consider a person pushing horizontally into a vertical wall with his hands. What is the direction of the normal force that the wall applies back to his hands? Is it A, left into the wall, B, straight up, C, right out of the wall, or D, straight down?